Okay, so we're talking about descriptive measures of data sets. And what was the first one we looked at on Wednesday? What did we look at on Wednesday? What kind of measures did we look at of data set? What's that? And what are those measures of? Okay, so measures of center. And then we also talked about like a different way to think about that. The measure of the center is really what about the data set? Okay, well that is the measure, but what is it a measure of? We're getting the mean, the median, and the mode. What are those numbers telling us? What are they? How are they helpful?
Representing the sample.
Representing
one number to represent the sample.
What about the sample? So the sample is all of them taken together. So the average, what is that? What does it tell us? Yeah.
Kind of guessing here, but is it the probability, like the highest probability, if you would, for example, pick one of those numbers?
Okay.
Probably be one of them would be closest to that number.
Okay, so yeah, so I think you were thinking the right thing, but the sample is all of them. So what measures of centers are is it's a number like what you would expect. Like it's a number just like the data values. It has the same unit as the data values, and it's like what you would expect for the data set. Okay, so what did we? So just looking back at this. So this was our grapefruit and watermelons, right? So if you have a sample of watermelons and all you know is that that a measure of center is 7 pounds, well then what you're saying is if you were just to pick a watermelon, you'd expect it to be about 7 pounds. That'd be your best guess. Your best guess would be 7 pounds. Now we know there's variability, but if you had one number to say what would you expect for a data value, it would be a measure of center. Okay, a measure. So that's the best we can do is just predict this. Yeah. To predict the center. If we get a mathematical way of having the center of all the data, then that's like a prediction of a data value. Make sense? So we'll always have the same units as the data values, and be a predictor of it or what we expect.
So it would be like your best guess.
Your best guess. The measure of center is like your best guess for the data values. If you were to pick one data value or pick another data value, it'd be your best guess at what that next data value would be. Okay, and then we talked about that they turn out to be different numbers and which one would be the best. So like we looked at data set 2 and we said that the mean was 474, the median 350, and the mode 300. And we said, okay, well, which one of those three measures of center would be the most indicative or the best one to expect for our expectation of the data? And we said because there were these two high kind of outliers, the 940 and the 1050, what that skews the mean, right? That skews the mean. It pulls the mean what direction? Up or down? It pulls the mean up from the general center of the data. So the data is skewed right. It's pulled up to higher values, where the general center of the data is more like, in this case, more like the median. So the median is kind of resistant to those outliers because it's saying half the data values above, half below. So the fact that they're way higher doesn't pull up the median. Okay, so we said the median and the mode here were better predictors of what we'd expect for data values in this case, because this is right skewed. Those very high values are pulling the mean up. Okay, so that's the idea of skew. And so when you have skew, then the median is a better measure of center to use when you have skew, because it's more like where the actual center of the data is. Okay, and then so now we're moving on to another thing to look at in a data set, and these are measures of variation. We talked about this. We said the two bowlers, they have the same average. They both have an average of 50. So if they both have an average of 50, are they virtually the same bowler? Are they virtually the same bowler? Yes or no? And the answer we said was no, because what's that? Consistency, exactly. One bowler could always shoot really close to 50, and another bowler could be all over the place. They both could have an expected value or a center of 50, but then that's two very different bowlers, right? That's two very different bowlers. Okay, so there's this other aspect besides the measure of center, the expected value. There's the measure of variability or variation in the data, and that's now those two things together now paint a bigger picture of what the data set is like. So let's go back. I want to show you. Let's go. So calculating what's called. So we calculate something called the standard deviation. The standard deviation. Okay, and so calculating the standard deviation is it's a complicated process. This is the formula for it. So let's. Why don't you practice here? We talked about these symbols last time. So there's basically three symbols here. So review, what does each of those symbols mean? So x sub I, x bar, and n. So get a partner and review. What are those symbols? X, xi, x bar, and n. And talk it out with a partner. Go. What is xi, what is x bar, and what is n? You need to know what those things are. Oh, there's one more symbol. This here. So xi, x bar, n, and then what is this symbol? Capital sigma. Okay.
Do we write the answers to whatever they are on the blue paper?
No, just we're talking right now. We're just talking. Okay, so what is xi? What is xi? I'm sorry? Okay, so I'm hearing two things. I'm hearing the data values and the sum of the data values. Which is it? It's just the data values, okay? It's just the data values. So xi is like x1 or x2. I can change, and then when I changes, you get different data values, etc. So xi just represents one of all the data values, and as I changes, you get you get different data values. Okay. X bar. That's the mean. Okay, n. Sample size or number of data values. Same thing. Sample size or number of data values. And then what does this symbol mean? sum of whatever comes after it, okay? Sum of whatever comes after it. So what are we doing here? So in this formula, just want to get a general, this formula is going to calculate what's called the sample standard deviation. The sample standard deviation is a measure of variability, okay? The bigger that number is, the bigger that S number is, the more the data is spread out. The smaller that number is, the more the data is consistently around the center, okay? So let's just generally talk about how this works. What would xi minus x bar be then? Xi minus x bar, what would that be a measure of? If you took a data value and subtracted the mean, what would that give you? Yeah, exactly. So you're looking at a particular data value. It's going to tell you its distance away from the mean. How far is that away from the mean? If it is the mean, then that distance is 0, right? If it's if it's far away from the mean, that'll be a large value. Okay. So in essence, what are we doing? We're going to do that for every data value. We're going to look at the distance from the mean. Okay, distance from the mean, and then we're going to square that. And then what are we going to do? We're going to sum all those up. So it's like we're summing up all of these distances from the mean. We're summing up all these distances from the mean, and then we're dividing by n. So look, we're summing a bunch of things up, and we're dividing by n. What is that? When you sum a bunch of things up and divide by n. It's like an average, right? So now there's a few differences. We're summing up the squares of the differences, and we're subtracting 1. We don't have to get into that. But in essence, essentially, this calculates what's under the square root, the average distance from the mean. Actually, the average distance squared from the mean. So we're saying, on the average, how far are the data values from the mean? And that makes sense. That's exactly what we're talking about, variability. On the average, if the distance from the mean is small, then they're all close together. And if on the average the distance from the mean is big, then they're further apart, further away, and you're going to get a larger standard deviation. Okay? So to find this number by hand is a long process, because you'd have to what? Find every distance from the mean and square all of those, and then sum all those up, and then divide by n minus 1, and then take the square root. So it's a lot of work, especially if you have a larger sample size. There's a lot of work involved in getting this number S. Okay, so that's why we want to use technology to do that for us, and then take the extra time that we have now that we've used technologies to really understand and interpret things. And oh, why do I touch it? Back. There we go. Okay. All right. So, but that being said, the technology seems to not be working. It's not working for me anyway. So here's what I want to show you. If someone has their laptop, if you could open up your laptop, the next assignment set is open. I want to show you what we're going to do once I figure out how we can. I gotta call customer support today. But if you have your laptop, will you please open it and go to the set that's now open. Or we can just go to last night's set. Okay, so you can't get to it. All right, so we'll go to, you should see homework 3, part 2 is now up. And let's just go to question 1 and see if that's a good one here. No. Okay, so here's 3.2.62. Click this icon to see the data. Okay, so there are 4 data sets there, and whenever they give you a data set, if you look right over here, there's this little icon that always give you, whenever they give you a set of data, there's this little icon here. And when you click on that icon, it's opening a program called StatCrunch. So this is technology that computes a zillion different statistics for us. So open in StatCrunch. So here's what I'm running into. So I want to see if it works for any of you. It's not opening for me. Last year it opened, fine. But I just get this spinning wheel that spins and spins and spins. So does it open for anybody else? It should open what looks like a spreadsheet or a big grid, and then the data will be in the columns. It works for you? Oh, sweet. So maybe it's just me. Anybody else? Does it work? Doesn't matter. And so, but I just went to this one, 3.2.62. So, do you want to come up and log in on the house computer, and then we can put it up on the screen for everybody. You don't need your laptop. Okay. So, the rest of you, are you able to? Does it open up in a spreadsheet with the data? Yes, it does. It works. Yes. Okay, great. It's working for you guys. Sweet. So I just got to figure out what my issue is.
Professor,
Yeah.
did you maybe try to turn off your pop-up blocker settings?
Yeah, I worked at it for an hour. I tried everything. I tried reinstalling Java. I tried pop-up blocker. I tried everything. So we're going to switch to. So we'll just show it through his. So I want you to go. Oh yeah. You can do my stat laptop. My stat. So while we're getting his set up, so jot down these values if you didn't already of the 2 data sets. Okay, so we're gonna run these data sets in the StatCrunch. So okay, so now watch. I just want to make sure you guys see again what you're gonna do. Okay, so what you're going to do is, whenever there's a data set, so here you have to click an icon. Sometimes they just give you the data set in the problem. Sometimes you have to click an icon. Whenever you see the data set, you'll see that thing right there. You're going to click on that, and then it'll say Open StatCrunch, and you should get this grid or this spreadsheet with the data in it already. Okay? Now, we're going to do the bowl. We're not going to do this one. This one you'll do for homework. So we're going to do the bowling one. So can you select them all and delete them out? So, let's see. All right, so we'll just leave those there, and we'll start a new column. Okay, we're going to start a new column over here. Say variable 6 and variable 7. So I think you're good. Okay, thank you very much. Okay, so the data. So we're going to put the data in. So if you can just enter your own data in a blank column, like we're going to do for the bowlers, or if you click on that icon from the homework next to the data set, it just automatically puts the data in there. Okay, so you'll work on this one for your homework, but we're going to do the bowlers. So just come over here to a blank column, and the bowlers were, it was 41. The scores 41, 44, 45, 47, 47, 48. 51, 53, 58, and 66. That's bowler number 1. I'm going to put that in column for 6, variable 6. And then variable 7 will be bowler number 2. And so I'll go 20. And how did bowler number 2 compare to bowler number 1? Less consistent, more erratic, right? He's a more erratic bowler. He could have a really good game or then a really lousy game. But then overall, the average of the two is the same. The expected center value, the same at 50. Both averaged 50. Our best guess for a score that they would bowl is 50. Our best guess for a score but we know that the first one's are a lot more reliable, right? And the second one, a lot more scattered in its scores. So let's see how the numbers play. So what we can do is then we can we don't need to do that. So we can go to stat. Okay, go to stat. Click on this right here, stat. And then we can do summary stats. Okay, summary stats, columns. And what do we want? We want column what? Variables. So column 6. Okay, you don't have to do these. And then, so right now, we're just going to select. So we have all these choices. So what does n mean again? Number of data values. We know what the mean is. Okay. So here's the variance and the standard deviation, right? So the variance and the standard deviation, these are measures of variability. So the formula we looked at was which one? Standard deviation, okay? So that's the one we're going to be interested in. But all these ones that are highlighted now are the values. So here's median, range we'll talk about, min. So now I lost the highlighting. So anything that's highlighted then is put over here, and so all these in this column over here are what the computer is going to tell us when we compute. Okay, so we can pull from all these, choose from any of these over here, and when you see them over there, then when we hit compute, those are the values it's going to do for us. Okay, so here we go. Ready? Compute. And so it's telling you the column variable 6, this is our first bowler, had 10 scores, right? Mean of 50, we already knew that, right? We already knew the mean was 50. And so then here's the new number we want. So we're going to round to 7.41, okay? Our standard deviation 7.41. That's a measure of how spread out his scores were. And I'm going to show you how it is in a second. Okay? Median, we know what that is. 47.5. And then the range, min and max, we'll talk about that in a second. Now, watch this. So let's cancel. Cancel that out. I can start again. Really, we wanted all that information about 2 data sets, right? So if I go to stat, start again, summary stats, columns. Look, I can choose them both at the same time. So I can choose variable 6. Get them both here. And then what did we want? We wanted all those things we had before. Compute, and then it shows me both at once. Okay, and it shows me both at once. Okay, so now what did we say about the second bowler compared to the first?
Very erratic.
More erratic. Okay, where do we see that in the numbers here?
The variance and the standard deviation.
Yeah, so we're focusing on the standard deviation. First bowler had a standard deviation of 7.4. We said that bowler was more consistent. Second bowler, 14.1. Okay, and what did I say? The higher the standard deviation, the more variable the data. And that's exactly what we expected. That bowler's more erratic. Okay, more erratic. So I want to show you, let's see, so write those numbers down. So make sure you have the those 2 standard deviations for the 2 bowlers down. I'm going to flip back to my laptop. So both had a mean of 50, but so the standard deviations were
Older one was 7.41.
7.41 and
And then 14.16.
we'll do 14.2. Okay, so let me show you how. If we made a scale here, 30, 40, 50, 60, 70. Okay, so this is just like a number scale here, a number line. So what we can do to kind of see how this number plays into the variability is we can make ranges around the mean. Okay, ranges around the mean by numbers of standard deviations. So for instance, the first range is going to be 1 standard deviation above the mean and 1 standard deviation below the mean. Okay, so what will that be? So 50 we know is the mean. So how far is it to 1 standard deviation above the mean? What would that number be? 57. So this is 50, our mean. And so then if we add 1 standard deviation, we get 57.41. And then if we subtract 1 standard deviation, we get 42.59. Check that for me. 59. So this is the range of 1 standard deviation above and below the mean. Okay? And now we're going to do a second range of 2 standard deviations above and below the mean. So that would be add another standard deviation to 57.41. So you're going to take the 57.41, it's in red, and you're going to add out, what is it?
64.82.
Almost 65, 64.82. And then down here, subtract it. You're going to take 42.59 and subtract 7.41.
35.18.
Thank you. Okay, so the red range, what? The red range is 2 standard deviations below the mean to 2 standard deviations above the mean. The blue range is 1 and 1. So it's from 1 below to 1 above. The red range from 2 below to 2 above. And then I'll do black, will be 3. One more time. 70 what? And 20 what?
72.23.
Thank you. So that final range is, this is 3 standard deviations below the mean to 3 standard deviations above the mean. So here's why we do that. Here's why. About 68% of the data will fall in the blue range. So the blue range, about 68% of the data values fall within that range. In the red range, about 95% of the data values fall in the red range. And then the black range, 3 standard deviations above and below, is about 99% of the data. So let's see if that came true. So we'll make a little dot plot here and see if that's about right. So 68% of 10 is about how many data values? 68% of 10. Can we do that in our head? We should be able to. 68% of 10 is about how many? 7, right? Close to 7. 95% of 10 is going to be like 9 or 10. About 9 or 10. 99%, we expect all 10 to fit within 99%. So we'll quickly make a dot plot here, and then we'll see if that came true. So here's 41, right? 41, 44, 45, 47, 47, 48, 51, 53, 58, 66. So now we count. How many of those data values in our dot plot fell within the first range? So we count. So this one, no. But this one, yeah, this one, yes. 1, 2, 3, 4, 5, 6, 7. And then this one was 58, so no. So how many did we get? 7 data values fell within the range of the first standard deviation, which is what you guys predicted, because it's normally around 68%. How many data values fell within 2 standard deviations? So we'd start again here. We got 1, 2, 3, 4, 5, 6, 7, 8, 9. But now this one's outside of that second range. Do you see that? 9. And that's about 95%. And then how many fell within all 3? All 10. So these, for this particular data set, these numbers were good predictors, right? So we got 7 in the blue range, we got 9 in the red range, and then we got all 10 in the black range, which fits with those percentages. So what would happen if the standard deviation was bigger? Then what would happen to these ranges? They would be further out, and then you'd have 68% in a further out, and then 95% further out, and then so with bigger standard deviation and the same percentages of the data, your data is more spread out. So for your blue sheet, you're going to do this for data set 2. You've got the standard deviation of 14.2. I want you to make the data ranges, make the dot plot, and count how many of each data value are in the 3 ranges. Agree? Okay, so there's one more thing. There's another real simple measure of variability, and that is called the range. Okay? The range of the data is simply the distance from the lowest data value to the highest data value. Really easy, right? So what would it be? The range would be how far it is, what's the span of data values from the lowest 41 to 66. How would you figure that out? How would you figure out how far it is from 41 to 66? Subtract. You take the max and you subtract the min, and what do you get? 25. So the range for the first bowler is 25 pins, right? 25 pins is their range. And so that's somewhat also of an indication of how spread out the data is, right? But notice it doesn't take into account anything in the middle. It totally ignores all the other data values in the middle. But it's something of a measure of variability or a measure of variation, okay? So for your second question, I want you to find the range of the second bowler. So mark it off somewhere where it's easily found, okay? So don't hide it within the first set of work. So distinguish it and make sure it's easily found. What's the range of the second bowler? And let's do then the range of the first bowler, show the work, and then just maybe a quick sentence on what those bowlers are like based on the two ranges, right? So based on the range of data set 1 and data set 2, what would you conclude about the variability of those two bowlers or those two data sets based on the ranges? So here's two more data sets, basketball teams. How would you find the range of team 1 and the range of team, this is not for the sheet, we'll just talk it through, not for the sheet. How would you find the range of team 1 and the range of team 2?
Team 1 would subtract 72 from 78.
Right, which would be?
Which would be 6.
6. So the range for team 1 would be 6. The range of their heights in inches. So 6 inches apart in their heights. And then the range for team 2, take 84 minus 67, 14. Okay, so again, just by looking at the max and the min is something of an indication of variability. But again, it ignores all the data in the middle, right? Ignores all the data in the middle. Whereas your standard deviation takes into account every data value, right? Your standard deviation takes into account all the data values. Any questions? So the two that you'll be for the homework would be standard deviation, which you can use StatCrunch every time. Let StatCrunch do the work for you to get that number. And then range, that would be the simple calculation. Find the max, find the min, subtract. Okay, any questions? So remember, you're looking for that little icon to the right, a little square icon to the right of any time you see a data set in the homework. Just click on that icon, and then you're going to have your data values in the columns. Click on Stat, select the ones you want, and compute, and it gives it to you. Okay? And I will see you Monday